June 6, 1944, somewhere near Rouen, France. The metallic glint of a damaged P-51 Mustang descended through broken cloud cover, its Packard Merlin engine trailing a thin ribbon of smoke. Lieutenant Thomas Fraser of the 334th Fighter Squadron, 4th Fighter Group, had lost his bearings during the chaos above the Normandy beaches. His fighter, bearing the squadron code QPG and nicknamed Jerry, struck the French countryside hard. Fraser survived the crash landing and would spend the remainder of the war as a prisoner of war. But his aircraft, serial number 4324825, a P-51 model, was about to embark on a journey that would profoundly shake the assumptions held by some of the Luftwaffe's most experienced test pilots. The Mustang lay relatively intact in that French field, soon to be recovered by German salvage teams who had perfected the systematic art of retrieving crashed Allied aircraft across occupied Europe. Within weeks, this particular machine would be transported to Berlin, the Luftwaffe's primary testing facility, located approximately 100 kilometers northwest of Berlin in Mecklenburg, where it would undergo repairs using components cannibalized from other less repairable wrecks scattered across German-controlled territory. The aircraft would emerge wearing German markings, its fuselage bearing the Luftwaffe code T9 plus HK, its tail and undersides painted in bright RLM04 yellow for easy identification by German pilots who might otherwise mistake it for an enemy aircraft during flight operations. The propeller spinner received yellow paint and a red band adorned the nose of the engine cowling. Following standard Luftwaffe identification procedures for captured aircraft, this Mustang was destined for service with one of the Luftwaffe's most unusual and specialized units, the Wunder Circus Rosarius, where it would force German fighter pilots to confront an uncomfortable reality about American engineering prowess, industrial capabilities, and their own increasingly untenable tactical situation in the deteriorating air war over Europe. The history of how captured enemy aircraft became instruments of revelation for the Luftwaffe begins not with Ferracier's forced landing on the day of the Allied invasion, but with the escalating air war over Europe and the desperate need for accurate, systematic intelligence about Allied aircraft capabilities that went beyond fragmentary air combat reports. By mid-1943, the Luftwaffe faced a strategic crisis that threatened to overwhelm German air defenses despite the considerable skill and courage of individual pilots and the ongoing development of advanced aircraft designs. American bomber formations were penetrating deeper into the Reich with each passing month, protected by fighters whose true capabilities remained partially mysterious to German commanders, who had to make tactical and strategic decisions based on incomplete information intelligence. Reports from combat pilots provided fragmentary air accounts of enemy aircraft performance, but these reports often conflicted with one another and reflected the chaos and confusion of aerial combat rather than systematic controlled analysis under consistent conditions. Hedman Theodor Rosarius, an experienced Luftwaffe officer, understood that German fighter units needed more than scattered combat reports and second-hand accounts to counter the Allied threat effectively. They required hands-on experience with captured enemy aircraft, structured opportunities to fly these machines under controlled conditions, and systematic evaluation to discover their strengths and vulnerabilities through direct observation and testing. The concept was not new. Both the Allies and Germans had tested captured aircraft throughout the war. But Rosarius would organize and systematize the approach in ways that maximized its tactical value. In 1943, following orders from General the Jagdflieger Adolf Galland, Rosarius formed what would become known as the Wunder Circus Rosarius, Officially designated as the second staff of the Versuch- und Oberkommando der Luftwaffe, the Trials and Research Unit of the Luftwaffe High Command. This specialized unit received all repairable captured Allied aircraft that German salvage teams recovered from crash sites across occupied Europe, from France to Italy to the Eastern Front. The unit's mission extended well beyond simple static testing at secure facilities behind the lines. Rosarius organized traveling demonstrations where captured aircraft would visit operational Luftwaffe fighter bases across Germany and occupied territories, allowing frontline pilots to examine these machines up close, observe them, perform aerial demonstrations, and in carefully selected cases fly mock combat missions against them. The program addressed a fundamental problem in pilot training that had become increasingly critical as the war progressed and pilot attrition increased. German fighter pilots trained primarily against their own aircraft, learning tactics optimized for fighting opponents who flew and fought like Germans, using similar aircraft with comparable performance characteristics and employing tactical doctrines that emerged from shared training and doctrinal foundations. This created a dangerous blind spot when engaging Allied pilots whose aircraft possessed markedly different performance characteristics, especially regarding range, high altitude capability, and sustained speed, and whose training emphasized different tactical approaches that leveraged these specific advantages. The recovery operation for Allied aircraft had become highly systematized by 1944 with specialized German salvage units operating across occupied territories under the direction of Belgian Battalion or salvage battalions. These teams worked with remarkable efficiency to secure crash sites, assess damage, and transport repairable aircraft to centralized testing and repair facilities before advancing Allied forces could recapture the wrecks. The organizational structure reflected German military thoroughness even as resources grew scarcer. The scale of Allied air operations over Europe made captures inevitable through sheer statistical probability. With thousands of sorties flown monthly by American and British forces, mechanical failures, battle damage, navigation errors, fuel exhaustion, and weather-related incidents resulted in numerous forced landings on German-controlled territory. Not all of these aircraft were destroyed on impact or rendered irreparable by crash damage. Some pilots, recognizing their situation was hopeless, executed controlled crash landings that left their machines largely intact, sometimes even with minimal structural damage that could be repaired with available resources and components. Fraser's P-51 B-15NA fell into this category of repayable captures. The aircraft had sustained damage during the intense fighter sweeps supporting D-Day operations, forcing an emergency landing in territory that remained under German control despite the invasion. German recovery teams reached the site within hours, following established procedures for evaluating crash sites. They examined the Mustang carefully, assessed the extent of damage, and determined that despite battle damage and crash impact, the airframe remained sufficiently intact for repair and restoration to flight-worthy condition. The aircraft was carefully loaded onto a specialized transport and sent to Rechlin, where experienced technicians and engineers worked systematically to restore it to flying condition. Rechlin Testing Center, formerly known as Sarabong, stellar wreck and located near Lake Muritz, served as the Luftwaffe's primary facility for evaluating new German aircraft designs and conducting detailed testing of captured enemy types. The facility, which had been officially designated the Luftwaffe's Central Testing Facility on February 26, 1936, included extensive workshops equipped with specialized tools, comprehensive test ranges for various evaluation protocols, and runways specifically configured for evaluation flights under controlled conditions. Technicians at Rechlin possessed considerable skill in reverse engineering and repairing, Allied aircraft, despite lacking original technical manuals, factory specifications, and genuine spare parts manufactured to original tolerances, the repair process for Fraser's Mustang required substantial ingenuity and resourcefulness that spoke to both German technical competence and the increasing challenges of working with limited resources. Technicians cannibalized components from other crashed P-51s recovered across Europe, building an inventory of parts that could be matched and fitted to create one flight-worthy aircraft from multiple damaged machines. The Packard 51 1653 Merlin engine, a license-built version of the Rolls-Royce Merlin 63 with ATWO stage 2-speed supercharger that produced 1,490 horsepower at 13,650 ft using 61 in of mercury boost pressure, underwent detailed inspection and necessary repairs using replacement parts obtained from multiple sources. This engine represented a significant technological achievement, delivering substantially more power at altitude than single-stage supercharged engines through its sophisticated intercooled two-stage supercharger system. The aircraft's 450 caliber Browning M2 machine guns, mounted 2 per wing in the P-51B configuration, were removed and replaced with ballast weights to maintain proper weight distribution and center of gravity, as German regulations strictly prohibited arming captured aircraft used for testing and demonstration purposes. This restriction reflected both safety considerations and concerns about captured aircraft potentially being used against German forces if they fell back into Allied hands through mishap or defection. Control surfaces were thoroughly examined for structural integrity and proper operation. Hydraulic systems underwent pressure testing and inspection for leaks. Fuel tanks were carefully inspected for damage, cracks, and potential leak points that could cause catastrophic failure during flight operations. The Razorback canopy design that characterized the P-51B was carefully preserved and repaired, though German pilots would later note how the framed canopy restricted rearward visibility compared to the bubble canopy introduced on the later P-51D variant. After weeks of meticulous work by skilled technicians, working with limited resources and improvised solutions, the Mustang was declared ready for initial test flights. German test pilots approached their first encounters with captured American fighters with professional curiosity mixed with considerable skepticism born from years of Luftwaffe propaganda. Official information had consistently portrayed American aircraft as crude mass-produced machines that prioritized quantity over quality, emphasizing manufacturing ease and simplicity, rather than sophisticated engineering and refined performance. The prevailing view among many German pilots, reinforced by official communications, held that American engineering focused on producing adequate numbers of acceptable aircraft rather than pursuing the engineering excellence and performance optimization that characterized the best German designs. These comfortable assumptions began dissolving rapidly the moment experienced German test pilots climbed into the Mustang's cockpit and experienced firsthand what American designers and engineers had actually achieved through careful design, sophisticated engineering, and meticulous attention to operational requirements. The cockpit layout of the P-51B immediately impressed German pilots familiar with the cramped confines of Messerschmitt Bf-109 cockpits and even the more spacious accommodations of Fowler-Wolf FW-19Os. The Mustang cockpit demonstrated thoughtful ergonomic design with controls logically arranged and positioned within easy reach, reducing pilot workload and allowing concentration on tactical situations rather than struggling with aircraft systems. Instruments were clearly marked with easily readable gauges and sensibly grouped by function, following human factors principles that prioritized pilot effectiveness. These yet provided noticeably better comfort than German fighters, an important consideration during multi-hour missions where pilot fatigue could significantly impact performance and decision-making. Visibility, even in the earlier Razorback configuration with its framed canopy, exceeded what BF-109 pilots experienced with their heavily framed canopies, restricted sight lines, and particularly poor rearward visibility that left German pilots vulnerable to attacks from behind. But the true revelation came when German test pilots advanced the throttle and felt the Packard 516-503 Merlin engine respond with smooth progressive power delivery. The power built steadily and predictably as the Mustang accelerated down Recklin's runway, the four-bladed Hamilton standard propeller biting efficiently into the air. The takeoff roll was noticeably shorter than expected for an aircraft of the P-51's weight and size. Clear testimony to the engine's substantial power output and the airframe's efficient aerodynamic design that minimized drag throughout the speed range. Once airborne, the Mustang demonstrated handling characteristics that fundamentally challenged everything German pilots thought they understood about American aircraft design philosophy and engineering capabilities. The flight controls were beautifully harmonized with aileron, elevator, and rudder forces perfectly balanced across the entire speed range from approach speeds to maximum velocity. Control forces increased predictably with speed, providing good feedback without becoming excessively heavy, and decreased smoothly at lower speeds without becoming overly sensitive or twitchy. The Mustang responded crisply and predictably to control inputs without displaying the oversensitivity or nervous handling characteristics that plagued some fighters. Roll rate exceeded that of the BF-109 significantly and approached the exceptional roll performance of the FW-19, allowing rapid changes in flight direction that were critical for both offensive and defensive maneuvering in combat. The aircraft could be thrown aggressively into various maneuvers, without displaying any troubling tendency toward departure from controlled flight, spin entry, or other dangerous characteristics that could prove fatal in combat situations. German test pilots systematically evaluated the Mustang's performance envelope through carefully planned test flights, pushing the aircraft through standardized maneuvers specifically designed to reveal its strengths, limitations, and any hidden dangerous characteristics. Climb. Performance impressed them considerably and generated significant concern about tactical implications. The P-51B could maintain excellent climb rates to altitudes well exceeding 30,000 ft, where the two-stage supercharged Merlin engine continued producing substantial power, even as the progressively thinner air at altitude severely degraded performance in German fighters equipped with single-stage superchargers. High-altitude performance particularly concerned German pilots and tactical planners because American bomber formations typically operated between 25,000 and 30,000 ft, where the air was thin and cold, but defensive fire from bombers remained effective against fighters that had to slow down toe tack. German fighters equipped with single-stage superchargers struggled increasingly to intercept effectively at these altitudes, their engines gasping for sufficient air, while the Mustang's sophisticated two-stage Merlin continued delivering robust, reliable power. Their revelation proved sobering to pilots and commanders who understood the implications. The Mustang could not only escort bombers to these altitudes, but could fight there effectively, maintaining speed advantage and maneuverability. While German interceptors labored with reduced power, slower speeds, and degraded handling as their engines fought against the thin atmosphere. Speed. Trials conducted under controlled conditions at various altitudes confirmed the Mustang's clear superiority in this critical performance category. The P-51B could achieve approximately 440 mph at optimal altitude with the engine running at military power settings. significantly faster than the Messid Bf-109G's approximately 386 mph and the Fowler-Wolf FW-908's approximately 48 mph when measured under comparable conditions. This substantial speed advantage proved tactically decisive in combat because it fundamentally allowed Mustang pilots to dictate engagement terms according to their advantage. American pilots could choose when to engage, pursuing fleeing German fighters when the tactical situation favored attack. Equally important, they could choose to disengage from unfavorable encounters, accelerating away from German fighters that lacked sufficient speed to pursue or force continued combat. German pilots discovered they could not force combat on a Mustang, whose pilot recognized an unfavorable situation and chose to avoid engagement, fundamentally undermining German tactical flexibility. The wing design of the P-51 based on NACA. Laminar flow airfoil sections gave the Mustang its distinctive appearance and delivered exceptional aerodynamic efficiency. Though German engineers noted that achieving true laminar flow in operational conditions remained elusive due to manufacturing tolerances, surface imperfections, rivets, paint, and operational wear. Nonetheless, the P-51's wing generated substantial lift with minimal drag compared to conventional airfoils, significantly contributing to the aircraft's remarkable range and fuel efficiency. This wing design maintained its effectiveness across a remarkably broad speed range from relatively low speed handling during landing approaches through high-speed performance during combat maneuvering, providing consistent, predictable handling characteristics that reduced pilot workload and enhanced combat effectiveness. Dive performance revealed yet another area where the Mustang demonstrated clear superiority over German fighters. The aircraft could dive at very high speeds without encountering the severe control stiffening and reduced control effectiveness that plagued many fighters when approaching or exceeding their maximum design speeds. Pilots could pull out of steep high-speed dives without requiring excessive physical effort or fighting against locked controls, and the airframe remained stable throughout the maneuver without tendency toward flutter, buffeting, or structural failure. German test pilots noted this capability with particular interest and concern because diving attacks represented a primary German tactical doctrine for engaging bomber formations and escorting fighters, attacking from altitude to build speed and energy before pulling back up. The Mustang's ability to follow German fighters through high-speed dives and maintain full control authority throughout the maneuver eliminated a key German tactical advantage. Turn performance presented a more complex and nuanced picture that required careful analysis. The Mustang could not match the sustained turn rate of the Bf-109 in level flight at moderate speeds, particularly as the Bf-109 benefited from leading-edge slats that automatically deployed during high angle of attack maneuvering and delayed wing stall during tight turns. In sustained slow-speed turning fights at medium altitudes, the lighter and more compact Bf-109 held a measurable advantage in turn radius and turn rate. However, German pilots discovered through systematic testing and mock combat that the Mustang's clear superiority in speed and climb rate allowed skilled pilots to avoid sustained turning engagements entirely and instead fight using energy tactics. The Mustang excelled at converting speed to altitude and altitude back to speed efficiently, enabling pilots to maintain energy state throughout combat maneuvering. This capability allowed Mustang pilots to engage when advantageous and disengage when threatened, forcing combat on their terms rather than accepting the enemy's preferred combat geometry. The Mustang's structural strength and robust construction impressed German engineers who examined the airframe in systematic detail at both Rechlin and at Göttingen, where more detailed technical evaluations occurred. The aircraft was substantially built with significant safety margins, engineered into critical structural components throughout the airframe. This robust construction philosophy contrasted markedly with German design approaches that often pushed structural limits to absolute minimums in pursuit of weight reduction and maximum performance. The P-51 could sustain significant battle damage that would have destroyed lighter German aircraft and still successfully return to base, a capability that directly translated into pilot survival rates and aircraft availability for subsequent missions. American engineering philosophy clearly emphasized survivability and maintainability, accepting somewhat higher empty weight in exchange for durability that kept aircraft and pilots in combat longer. Range capabilities astounded. German pilots accustomed to the severely limited endurance of their own fighters, which rarely exceeded 90 minutes of total flight time, including combat. The P-51B carried substantially more internal fuel than the Bf-109 or FW-190, and the aerodynamically efficient wing design translated this fuel capacity into truly extraordinary range that seemed almost incredible to German pilots. With external drop tanks attached under the wings, the Mustang could fly missions exceeding 8 hours duration, covering operational distances that seemed nearly impossible to German pilots, whose combat radius barely exceeded 200 mi under optimal conditions. This massive range advantage fundamentally transformed bomber escort operations in ways that proved strategically decisive early in the war. German fighters could simply wait until shorter-range Allied escorts reached their fuel limits and turned back toward their bases, then attack unprotected bombers during the most dangerous portions of their missions deep in German territory. The Mustang completely eliminated this tactical window. American escorts could now accompany bombers throughout entire missions deep into Germany and back to England, preventing German fighters from ever finding truly vulnerable targets. The strategic implications were profound and deeply troubling to Luftwaffe commanders who understood that German fighters now had to fight their way through escorts to reach bombers, dramatically increasing the risk German pilots faced on every interception sortie. German pilots who flew captured Mustangs in both test flights and mock combat consistently reported being profoundly impressed by the aircraft's harmonized handling characteristics and overall ease of operation. The flight controls required neither excessive physical strength nor excessively delicate touch, striking an ideal balance that allowed pilots to fly aggressively and precisely without fear of over-controlling the aircraft or inadvertently losing control during violent maneuvering. This forgiving ease of handling meant that average pilots could extract good performance from the Mustang under most conditions, while exceptional pilots could achieve remarkable results by fully exploiting the aircraft's capabilities. Maintenance accessibility surprised German ground crews familiar with the sometimes extraordinarily difficult servicing requirements of Bf-109 and FW-190s, particularly when working under field conditions with limited equipment. The Mustang's engine cowling opened in multiple sections that provided excellent access to the Merlin engine and its accessories, fuel system, hydraulic components, and electrical systems. Panels throughout the airframe could be quickly removed to reach internal systems for inspection, adjustment, or repair. The overall design clearly reflected American emphasis on rapid maintenance turnaround and high operational availability. Recognizing that aircraft sitting on the ground awaiting repairs contributed nothing to combat effectiveness, regardless of their theoretical performance capabilities. The Wonders Rosarius took the captured and repaired Mustang coded T9 plus HK on an extensive tour to operational Luftwaffe fighter bases across Germany during late 1944, visiting numerous locations where frontline fighter units were based. At each stop, The unit would establish temporary operations and set up comprehensive demonstrations, showing German pilots exactly what Allied aircraft could do in flight and teaching them specific tactics designed to counter Allied strengths, while identifying and exploiting whatever weaknesses could be found. The demonstrations typically began with captured aircraft taxiing past assembled German pilots and ground personnel, creating surreal scenes as enemy aircraft bearing German markings and bright yellow identification paint moved among German fighters. Seeing these aircraft up close had substantial psychological impact, making the enemy tangible and real rather than abstract. Then came flight. Demonstrations where experienced German test pilots would fly captured aircraft through carefully choreographed aerobatic routines and tactical maneuvers, demonstrating specific performance capabilities in ways that were far more effective than written reports or verbal briefings could ever be. For the Mustang demonstrations, test pilots would perform high-speed passes at low altitude to dramatically show the aircraft's significant speed advantage over German types. They would execute climbing maneuvers to altitudes exceeding 30,000 ft to display their remarkable climb performance and high-altitude capability enabled by the two-stage supercharged engine. They would demonstrate the P-51's excellent roll, right through a series of crisp aileron rolls that showed how quickly the aircraft could change direction. Mock dogfights against German fighters would illustrate both the Mustang strengths and the limited circumstances under which German fighters retained advantages. After the flying display concluded, pilots and ground personnel could approach the aircraft on the ground, examine it closely, inspect the cockpit layout and instrument panel, and ask detailed questions of the test pilots who had extensive experience flying the captured machine. These hands-on educational sessions proved invaluable for demystifying enemy aircraft and providing concrete, tangible understanding of what German pilots faced in actual combat operations. Most valuable and impactful component of these base visits involved mock combat sessions where captured Allied fighters would engage German fighters in carefully controlled simulated combat under observation. Selected experienced German pilots would fly their own operational aircraft against the captured types, experiencing firsthand how Allied fighters handled in dynamic combat situations and learning what worked and what proved ineffective against specific Allied aircraft. One such demonstration took place at an airfield hosting Yagashata 1 during late 1944 as Allied bomber operations intensified and German losses mounted. The base commander had arranged for several of his most experienced pilots to fly mock engagements against the captured Mustang to gain practical knowledge they could pass on to squadron mates. The German test pilot flying the P-51 demonstrated tactics that American pilots typically employed in actual combat, using the Mustang's clear advantages in speed and climb performance to maintain energy throughout the engagement while avoiding situations where the Mustang's lesser turn performance became a significant disadvantage. German pilots flying Messerschmitt Bf-109 Gießen-Faulf FW-19AOAs attempted to engage the Mustang using standard Luftwaffe tactics that had proven effective against earlier Allied fighters. They quickly discovered the extreme difficulty of successfully engaging a Mustang whose pilot understood and properly utilized energy management techniques and the aircraft's performance advantages. When German pilots pursued aggressively, the Mustang would simply accelerate away, opening distance faster than the pursuing German fighters could close it. When German pilots attempted to climb to gain an advantageous position above the Mustang for a diving attack, the P-51 outclimbed them, reaching superior altitude first and reversing the tactical situation. When German pilots tried to force a sustained turning fight where the Bf-109's superior turn performance should have provided advantage, The Mustang pilot would refuse the engagement by extending away using superior speed, then reverse back into the engagement with renewed energy advantage when conditions favored the attack. The mock combat sessions proved sobering for German pilots who'd believed or hoped that their aircraft and established tactics remained reasonably competitive with Allied fighters despite the deteriorating strategic situation. Directly observing and experiencing the Mustang's performance capabilities in dynamic combat maneuvering demonstrated clearly that American pilots flying P-51s possessed significant and fundamental tactical advantages, particularly at the high altitudes where bomber escort combat typically occurred. This pattern of revelation and gradually dawning realization repeated itself across numerous Luftwaffe bases where the Wunder Circus Rosarius conducted demonstrations throughout late 1944 and into 1945. German pilots received official assurances about the continuing superiority, or at least competitive parity of their aircraft during pre-demonstration briefings, then experienced actual combat and flight demonstrations that directly contradicted those optimistic assessments. The captured aircraft demonstrations provided concrete, undeniable evidence that German fighters faced formidable opponents whose capabilities significantly exceeded what propaganda and official communications suggested. Walter de Hall, who commanded fighter units during 1944, later wrote about Wunder Circus Rosarius visits to his bases in his memoir, though historians note his accounts must be treated cautiously due to documented reliability issues throughout his writing. He described how captured American fighters would arrive along with captured heavy bombers, creating unusual and somewhat surreal scenes where enemy aircraft parked peacefully alongside German machines while pilots examined them closely. Formation leaders received opportunities to fly captured aircraft in controlled mock combat, allowing them to understand Allied aircraft characteristics through direct personal experience rather than relying solely on second-hand reports and official briefings. Dahl emphasized the substantial value of this training, noting that familiarity with enemy aircraft capabilities represented a factor not to be underestimated in aerial combat, where split-second decisions often determined survival. Following these demonstration sessions, flight leaders would conduct detailed training lectures with their squadron members, passing along specific recommendations and tactical insights based on their personal observations and direct experience flying captured a light aircraft. This systematic knowledge transfer helped prepare German pilots for combat encounters with more realistic understanding of both Allied strengths and the increasingly limited circumstances under which German fighters retained exploitable advantages. The program achieved decidedly mixed results by late 1944 as Germany's strategic situation deteriorated across all fronts. While the demonstrations unquestionably provided valuable tactical intelligence and improved German pilot understanding of Allied aircraft capabilities, this knowledge could not overcome the fundamental and growing disadvantages German forces faced. The Luftwaffe suffered from chronic and worsening fuel shortages that severely limited flight training hours for new pilots, resulting in inadequately prepared pilots being sent into combat with minimal experienced pilots who understood through hard-won combat experience how to fight effectively against aircraft like the P-51 were increasingly rare. Lost to relentless attrition during the brutal air combat of 1944 that saw German fighter pilot losses reach unsustainable levels. Aircraft production, while remaining surprisingly high despite intensive Allied strategic bombing of German industry, could not replace losses quickly enough to maintain force strength. Most critically, the training revelations from captured aircraft often served primarily to demoralize rather than inspire as pilots realized the full extent of their disadvantages. German pilots recognized with growing clarity that they flew inferior aircraft or at minimum aircraft, inferior in the most critical performance categories for the missions they were assigned. The P-51's speed advantage, extraordinary range, and superior high-altitude performance could not be matched by any available German fighters in operational service. The technical intelligence gathered from captured Mustangs extended well beyond simple flight testing and combat evaluation. German engineers at both Rechlin and Göttingen systematically disassembled P-51 components to understand American manufacturing techniques, material selections, and detailed design approaches. They examined the wing structure and airfoil sections in meticulous detail, studying the construction methods and attempting to understand precisely how American designers had achieved such aerodynamically efficient performance. They analyzed the Packard 1653 Merlin engine with great interest, noting its sophisticated two-stage supercharger system with intercooler that enabled such impressive high-altitude performance. The fuel system received careful attention as engineers attempted to understand how American designers had achieved such remarkable range. The hydraulic systems were evaluated for their reliability and relative ease of maintenance compared to German systems. German engineers noted repeatedly the consistently high quality of materials used throughout the aircraft. American access to strategic materials like high-grade aluminum alloys, specialized steels, and reliable rubber compounds allowed designers to create structures that effectively combined strength with acceptable weight while maintaining production efficiency. Germany faced increasingly severe material shortages by 1944, forcing the use of substitute materials that often proved inferior in strength, durability, or manufacturing characteristics. The investigation of captured Mustangs revealed sophisticated manufacturing techniques that enabled true mass production without significantly compromising quality standards. American factories produced P-51s using highly developed assembly line methods that maintained remarkably tight tolerances and consistent quality across thousands of individual aircraft. German production had become increasingly reliant on dispersed manufacturing in smaller facilities scattered across the country to avoid concentrated bombing, sometimes using inadequately trained forced labor, resulting in inconsistent quality, reduced production efficiency, and increasing maintenance problems with operational aircraft. The captured Mustang, designated T9 plus HK, served with the Wonder Circus Rosarius until December 10, 1944, when the aircraft and its pilot Oberleutnant Leopschans were lost. Historical records do not definitively specify whether the aircraft crashed during a demonstration flight, was destroyed on the ground during an Allied air raid against the airfield where it was stationed, or fell victim to other wartime circumstances. By that point in its second operational life, the aircraft had traveled extensively across Germany, visiting numerous Luftwaffe bases and providing direct hands-on education to hundreds of German pilots who gained invaluable first-hand knowledge of American aircraft capabilities. Other captured Mustangs served similar evaluation and demonstration roles for the Luftwaffe. German records and post-war research indicate that at least two P-51s definitely operated with the Wander Circus Rosarius at various times during 1944 and early 1945, bearing the Luftwaffe codes T9 plus CK and T9 plus HK. Historical sources sometimes incorrectly list T9 plus FK and T9 plus PK as additional P-51s operated by the unit. But careful research reveals that T9 plus FK was actually a captured P-47D Thunderbolt, not a Mustang, while T9 plus PK was a captured Soviet Lavatkin Live FN fighter. The T9 designation code was not officially assigned to any existing Luftwaffe operational formation in German organizational records, strongly suggesting it represented an ad hoc code used specifically for Wanderer's Rosarius captured aircraft operations than following standard Luftwaffe organizational structure. Documentation indicates that one captured P-51B was used at Neuruppin Airfield, located approximately 60 km northwest of Berlin-Train. Hungarian fighter pilots won effective tactics for using their Fowler-Wolf FW-190s against American Mustangs. This transfer of tactical knowledge to German allies reflected recognition that the Mustang represented a significant and growing threat requiring specialized counter-tactics that needed to be disseminated widely. The training emphasized identifying and exploiting the limited areas where German and Hungarian fighters retained advantages, such as sustained turn performance at lower speeds and altitudes, while studiously avoiding situations that played directly to the Mustang's overwhelming strengths in speed, climb rate, and high-altitude performance. The broader implications of German pilots directly experiencing and thoroughly understanding superior American fighter extended well beyond immediate tactical considerations. The Mustang represented tangible, undeniable evidence that American industrial and engineering capabilities equaled or exceeded German achievements in critical areas, contradicting years of propaganda about American industrial and technical inferiority. This uncomfortable realization challenged fundamental assumptions about relative national capabilities and contributed significantly to declining morale among German pilots who increasingly understood they fought at a severe and growing disadvantage that no amount of skill, courage, or tactical cleverness could fully overcome. The Mustang's range capabilities particularly troubled German commanders because they clearly recognized the decisive strategic implications. The bomber war over Germany, which had seemed potentially containable when Allied escorts possessed limited range and had to turn back before reaching deep targets, became effectively unstoppable once Mustangs could provide continuous escort coverage throughout entire missions. German fighters could no longer wait for escorts to reach their fuel limits and turn back before attacking bombers. Every bombing mission now featured fighter escort throughout, dramatically increasing the risk German pilots faced when attempting intercepts and forcing them to fight through screens of superior Allied fighters to reach bomber formations. Production numbers told a devastating story about relative industrial capacity. By late 1944, American factories were producing approximately 500 P-51s monthly, and this figure would climb even higher, reaching 881 aircraft per month by January 1945 at peak production. This output exceeded more than double the combined production rate of all German single-engine fighter types, including Bf-109s, FW-190s, and newer types. Moreover, these Mustangs were equipped with reliable engines built to consistent quality standards, sophisticated and accurate instruments, and radio equipment that actually worked consistently and reliably, unlike the often unreliable and poorly manufactured equipment in late-war German fighters. American pilots flew aircraft that had been properly maintained by well-trained ground crews with adequate supplies of genuine spare parts, proper tools, and technical manuals. While German forces struggled with increasingly severe maintenance challenges created by parts shortages, substitute materials, undertrained or forced labor personnel, and dispersed maintenance facilities, the quality and thoroughness of American pilot training also became increasingly apparent through combat encounters analyzed by surviving German pilots. American pilots typically arrived at operational units with 200 to 400 hours of total flight training time, including extensive instruction in advanced combat tactics, instrument flying under various weather conditions, and formation procedures German pilot training had been dramatically and dangerously shortened by late 1944 due to severe fuel shortages and the loss of training facilities and experienced instructors. New. Pilots sometimes arrived at frontline units with barely 100 hours total flight time, minimal combat training, and often no instrument training whatsoever, leaving them dangerously unprepared for the reality of combat operations. These inadequately trained pilots faced veteran American pilots flying objectively superior aircraft, a combination that produced grimly predictable results reflected in German loss statistics. German loss rates among fighter pilots increased dramatically and unsustainably during 1944 and early 1945 experienced pilots who understood through hard-won combat experience how to maximize their aircraft's remaining strengths, while minimizing exposure to enemy. Advantages were killed or seriously wounded faster than replacement pilots could be trained, even under the compressed and inadequate training programs. New pilots with minimal training survived only a handful of missions on average before being shot down, bailing out if they were fortunate, dying if they were not. The Luftwaffe was hemorrhaging its most valuable and irreplaceable asset, skilled, experienced pilots with the knowledge and judgment necessary for survival and effectiveness at rates that could not possibly be sustained. The Wander Circus Rosarius demonstrations revealed these harsh realities directly to German pilots before they encountered them in actual combat, where the stakes were life and death. While this advanced preparation theoretically improved their chances of survival by providing realistic understanding of what they would face, it simultaneously made painfully clear the deteriorating situation German forces faced across all dimensions of the air war. Pilots who flew the captured Mustang or observed demonstration flights understood with uncomfortable clarity that they would confront opponents with significant and fundamental performance advantages in the specific areas that mattered most: speed, range, high-altitude capability, and overall numbers. This knowledge, while possessing some tactical value, contributed substantially to the severe psychological pressure German pilots experienced during late 1944 and early 1945 as strategic reality became impossible to ignore. Some German test pilots who extensively flew captured P-51s through multiple test flights and mock combat engagements developed grudging professional respect for American engineering prowess and design philosophy despite their position as enemies. They recognized through direct experience that the Mustang represented a coherent, well-integrated design that intelligently prioritized the characteristics most valuable for its intended strategic mission of long-range bomber escort. The aircraft deliberately sacrificed some characteristics like sustained turn performance that might have been optimized for pure dogfighting in favor of speed, extraordinary range and high altitude performance that enabled it to escort bombers deep into Germany and fight effectively throughout the mission. This represented sound engineering judgment that selected appropriate design compromises to achieve clearly defined mission objectives rather than pursuing theoretical performance maxima that didn't serve actual operational requirements. The Mustang's ease of production also impressed German engineers who understood manufacturing challenges intimately through their own experiences. The aircraft's design facilitated true mass production through modular construction that allowed parallel manufacturing, standardized components that reduced complexity and training requirements, and design features that deliberately simplified assembly operations. American factories could produce Mustangs in large numbers while maintaining consistently high quality because the fundamental design itself accommodated production requirements from the beginning. Rather than treating manufacturing as an afterthought, German aircraft designs often prioritized absolute performance over manufacturability, resulting in aircraft that were difficult and time-consuming to produce, even under optimal conditions, much less in the deteriorating circumstances of late war Germany. The Packard 516-503 Merlin engine that powered Frazier's P-51B and other early production Mustangs represented another critical area where American capabilities exceeded German achievements. The Packard Company successfully manufactured Rolls-Royce Merlin engines under license in the United States, producing many thousands of engines with remarkably consistent quality despite the complexity of the design. The sophisticated two-stage supercharger with intercooler enabled excellent and sustained high-altitude performance that German inline engines could not match. While the engine proved reliable and relatively maintainable under field conditions, German inline engines like the Daimler-Benz DB605 suffered from increasing quality problems during 1944 as severe material shortages forced the use of substitute materials and production dispersal. To avoid bombing significantly reduced quality control. Effectiveness. The psychological impact on German pilots, who thoroughly understood through direct experience the performance gap they faced, cannot be overstated or dismissed as mere morale problems. These men had entered the war confident in their superior training, the capabilities of their aircraft, and the effectiveness of their tactical doctrines. By late 1944, extensive combat experience and direct exposure to captured Allied aircraft through programs like the Wunder Zirkus Rosariuschad systematically eroded that confidence. They recognized with painful clarity that they fought opponents who possessed decisive advantages in aircraft performance, overwhelming numerical superiority, better logistics support, more thorough training, and superior intelligence flying. Combat missions under these conditions required extraordinary courage that bordered on fatalism and acceptance of likely death or severe injury. Former Luftwaffe pilot accounts and post-war interviews from this period frequently describe the hopeless feeling of watching American fighter formations appear on the horizon and knowing intellectually that those escorts could not be avoided through any tactical maneuver and could not be outrun by any German fighter in operational service. German pilots understood that engaging Mustangs at high altitude meant fighting at severe disadvantage in every performance category that mattered. Declining. To engage meant allowing American bombers to strike targets unopposed, accelerating Germany's military and industrial collapse. Neither option offered acceptable outcomes from a professional military perspective. Yet these were the stark choices German fighter pilots faced daily during the final year of the war. As their strategic situation deteriorated beyond any possibility of reversal, the Wanderers Rosarius continued operating into early 1945, conducting demonstrations with various captured aircraft as long as aviation fuel remained available in sufficient quantities, and operational airfields could be maintained against Allied ground advances from both east and west. As Allied forces advanced progressively deeper into Germany from multiple directions, the unit's ability to travel safely to operational bases to conduct demonstrations diminished steadily.